Hi everyone from Miss Piezas' house. I've missed you all, so I thought I'd do a little video for you and we could have a little bit of fun with a science experiment. Today we're going to work with liquids, and liquids don't hold their shape. So if I pour water from this glass to this glass, it fills that glass up. It doesn't just stay in the same shape. Same thing goes with juice. If you spill juice on the floor, it takes the shape of the floor. There are lots of different kinds of liquids. This oil is a liquid. This food coloring is a liquid. Water we already know is a liquid. We already know that juice is a liquid. And I'll bet you can think of lots of other liquids. But did you know that liquids don't all weigh the same? Liquids have density. And that means how closely together their molecules are packed. Some, like oil, have fat molecules and they float really well. Water is very dense and packed together really tightly, so it sinks. So let's see what happens when we put some oil and water. Now let's watch this. Let's pour a little bit of oil in there and look what happened. All of that oil is in those bubbles at the top, and I can swish it around, but those bubbles, they don't move. The bubbles are all at the top. Now, that means that they're floating, and things that float are lighter, right? So the oil is actually lighter or less dense than the water. What do you think about food coloring? Let's add some yellow food coloring and see if it's less dense or more dense than water. Let's watch it and watch what it's doing. Well, that looks to me like the yellow food coloring is mixing with the water. Let's pull this up just so you can see it a little bit better. You see the yellow food coloring is mixing with the water. So they're the same density. Things that are the same density can mix together. If the water were lighter, all of the food coloring would go to the bottom and it wouldn't mix. The water would sit on top. If the water were heavier and the food coloring were lighter, then the food coloring would sit on top like it does here. So let's do an experiment and let's see. I'm going to put some oil into this glass. Let's move this one out of the way so that you can see what I'm doing. So I've put some oil in the glass, and now I'm going to put some food coloring in. Here's red. 1, 2, 3, 4, 5. Here's some yellow. Here's some green. And here's some blue. Can you see that it's all bubbles? You see all the really cool bubbles on top? Can you see that? They look really cool. So what will happen if I pour this water or this oil in this water? Make a prediction as I'm doing it. Did you see? It all mixed together. And that's the really cool thing, because now that they're all mixed together, they look kind of brown. Looks kind of like soda. Don't drink it. It won't taste good. But our bubbles popped. Our food coloring bubbles popped and mixed into the water. So what does that tell us? My oil bubbles are still on top, so the oil is still less dense than the water. And as the little beads of food coloring pop, they're going down and mixing in. And now if you can look, I don't know if you can see it really well. I'll put a white paper behind it to see if you can see. But if you look inside the water, you can see that there are little fireworks going off too. It looks like fireworks streaming down. The colors are slowly filtering down. It looks really, really cool. So I hope you can see that. All right, so today we learned about liquids and density. If you wanted to try that experiment at home, you'll need food coloring, water, and some cooking oil. Make sure you ask your parents first. Stay safe and have fun, and I miss you. Until next time, bye.